Welcome everybody to the lecture on 21st of October, Supplier Management. Today, after we have seen safety stock and reorder point calculations and EOQ and single period, inventory model, and use vendor model and inventory review systems, we will finish our theory of inventory management with something called multi-echelon inventory systems. Which is basically a way to analyze supply chain networks. If you remember our first lecture, we saw a socio-technical model, and in the technical level, the last level was about supply chains. Okay, so we are going to be there today, and basically is a way to perform supply chain optimization. Okay. Next week we will perform a case study to look at all these theoretical problems in detail and how to solve them in real life. Okay, so first we start with an introduction. Why multi-echelon inventory systems? Okay. In modern supply chain, inventory is often spread across multiple locations. Such as central warehouses, regional distribution centers, and retail stores. Managing these inventories across different stages is critical to minimize cost and maintaining high service levels. Okay, this process is called multi-echelon inventory system. Okay, so in this lecture we will explore these multi-echelon inventory systems and how they differ from single location models. We will explore mathematical models for optimizing inventory levels, and we will see practical examples. Okay, so let's go then hit the trail. First step is the multi-echelon inventory systems. Okay, what is an inventory definition? What is a multi-echelon inventory system? It refers to a supply chain where inventory is stored at multiple locations, often referred as echelons. Each echelon represents a different level in the supply chain. Okay? Example. This is a definition. Okay. Example. We can have a retailer Imagine we're selling beer, okay? Here is the customer. Who wants to drink some beer. And the retailer is the grocery store of your area, okay? So this guy has some inventory. This is echelon retailer, okay? Then you have some warehouse in, I don't know, in Ludwigsburg, which is called the Regional Distribution Center. Echelon Regional Distribution Center. And here you have deliveries with a little truck twice per week. Okay, and then you have one factory of beer in München. Factory, echelon factory, and the factory delivers per truck. Every day. Okay? So each one of these echelons has some inventory, work in progress. Let's say 20,000 units. Okay? Usually this inventory is represented like this, or just a triangle. In the regional distribution center, you have 100,000 units. In the retailer, in the Reve of your area or Aldi or something, you have 1,000 units. Okay. And then you have your customer with an average demand equal 100 units per day. Okay, so you can represent your inventory also as your coverage time. In German it's called Reichweite. Measured in time. With 1,000 units, you can cover 10 days of demand. With 100,000, you can cover 1,000 days of demand. With 200,000, you can cover 200 days of demand. So your overall coverage in your supply chain is 1,210 days of demand. Okay? Any questions about this simple example? I need you to give me feedback, some thumbs up or something like that. You're cool? Okay, so it gets trickier later, but now it's kind of easy. Okay, this is just one, let's say 1, 1. Let's go for 1.2. Second is some key concepts. In multi-echelon inventory systems. So they introduce new complexities like single location models, which cannot be solved by EOQ or continuous review. So to manage these complexities, we introduce the following key concepts, okay? So we say 1.2.1 echelon stock refers to the total amount of inventory available in all locations upstream of a particular echelon. Okay. So, for example, the echelon stock of the retailer equals 100,000 plus 20,000. Which means equals 120,000. Okay? This is the echelon stock of the retailer. Then the second concept is the echelon lead time. It's the time it takes to replenish stock at a particular location. Considering both, consider all upstream echelons. So the echelon lead time for the retailer is the time delivery from distribution center to retailer plus time delivery factory to distribution center. So there are two sorts of policies that can be used in the multi-echelon inventory systems. For inventory management. The first is the installation stock policies. In which each location manages its own stock independently without considering the stock in upstream echelons. Upstream is to the left, okay? Okay. This is the classical push process. We represent it like this. Sometimes we have some ERP system, and then the ERP system is given information from customer demand, and this customer demand is being forwarded to distribution center or the factory. So everybody is just managing their own inventory. This leads to certain problems like bullwhip effect and so on and so forth. We will talk about that in the case study we will do next week and the next, okay? The second policy, it's so-called echelon stock policy. Each location bases its ordering decisions on the total stock available in its echelon. Which, as we have seen in the definition above, is the sum of its inventory and the upstream stock, okay? I guess I should change this. Wait a second. I think this is more accurate. The echelon stock in the retailer is the stock at the retailer plus the upstream stock. Please correct that, okay? I'm sorry about the trouble. Anyway, so we have two ways. This results into some pull process. And basically the way this is represented is like we don't have ERP anymore. We have some sort of Kanban or pull process between the echelons. Okay, and this is basically the way to do it if you want to have a more stable supply chain and less variability and so on. We will see that, as I said, in one example starting next week. Okay, so this is the demand. Any questions so far? Okay, Kaya, no problem. The rest, can you give some live proof? Margarita, Leonie, okay, Bogi, no questions. Okay. Well, then let's continue. This is just some concepts, key concepts. We have seen a definition of what is a MEIS, some concepts that are important, and now we go into the math models. For MEIS. Okay. We go to the first multi-echelon inventory system with continuous review. CR, okay. Here, just in an analog way as with the single inventory points, we monitor inventory levels at each echelon in real time and reorder stock when inventory falls below a predetermined reorder point. ROP. Okay. However, and this is important, unlike single echelon systems, the ROP is based on echelon inventory levels of the supply chain, not just local stock levels. Okay, so we not only look at the point, we look at everything. So this is the game we are playing, continuous review. We review continuously on time, and we have a predetermined reorder point, and we look at that based on echelon inventory. Okay, so how to deal with that? Reorder point for multi-echelon inventory systems. The reorder point at a particular echelon. So we have one reorder point for each echelon, is calculated by considering both echelon lead time the time it takes to replenish stock, we saw it above, and 2, demand variability. If you remember in the first class, we said on the technical level of our socio-technical system, here in the social level, we want to increase trust. Here on the technical level, we want to decrease variability. Variability, how do we measure variability of a system? Can somebody tell me? Or how do we measure variability of a KPI? Hello, somebody there? Variability is measured by the variance or its square root standard deviation, which is the number of demand points minus the demand mean divided by n minus 1, being the sum. This is just a reminder from your statistic class, okay? This is the standard deviation or this is the variance or the square root, the standard deviation. This is how we measure variability. So the general formula for the ROP in a multi-echelon inventory system is ROP sub E, so meaning in the echelon, demand times lead time time safety stock for the echelon. Okay, so this is the reorder point at echelon E. This is the average demand at echelon E. This is the echelon lead time. At echelon E, and this is the safety stock at echelon E based on demand variability. Okay, this is a super simple formula, okay, that actually simplifies lots of statistics. Okay, so you have noticed we don't have here no standard deviation. Okay, the average demand is here what we have, the average demand, to use the same nomenclature. Okay, so here the key difference compared with a single echelon is that the echelon lead time accounts for both the time to receive stock from the immediate upstream echelon and the time it takes for that echelon to receive stock from its upstream sources. Okay, so this is the important thing. Okay, let's make an example and you will see it's super easy. Okay, example. Consider a supply chain with 2 echelons, 1 and 2. Okay, echelon 1 a retail store, Aldi, okay, with an average daily demand of 50 units. Okay, a day. Good. And then echelon 2, a regional distribution center that supplies a store and receives inventory or stock from a central warehouse. So we cool? Lead times are as follows. From our DC to store, 2 days. From central warehouse to RDC, 5 days. The RDC keeps a stock of 100 units, and the store keeps 50 units. Okay. The standard deviation of daily demand at the store is 8 units. So, okay, so these are the data. This is what I would give you in the exam. And then I would say, okay, calculate the reorder point for the store. Okay? Problem statement, problem question, bam bam, calculate the reorder point of the retail store. So we cool? Any questions on the problem statement and problem question? No, Kaya, no, Margarita, everything cool? You can ask questions in German if you want to also, okay? So, the first step, step 1, is calculate the echelon lead time. We're gonna need it for the retail store. So the lead time for the retail store is the sum of all lead times from both the RDC and the central warehouse. So lead time retail store equals 2 days, okay, which is the lead time RDC to store plus 5 days, which is the lead time from warehouse to RDC. So this is 7 days. We can do it without a calculator even. Okay? So you cool with that? Good. The second step is to calculate the reorder point at the retail store. So reorder point at the retail store must cover demand during the entire echelon lead time. So the echelon lead time, 7 days, is the time it takes to get inventory from order to the retail store, right? So we go and say, well, our ROP, reorder point, on the retail store equals the average demand times the lead time at the retail store average demand at the retail store, sorry, RS times plus this is I put it wrong. This is a plus. Please correct it, okay? This is a plus. It's not a type, it's a plus. Safety stock. And the retail stock. So we can, here, to calculate the safety stock, we have two ways. One way, we get the Z value, as we saw the other day, or we know, just like in this case, for the Z value, we need the standard deviation, as we saw in the examples last week, or we know the safety stock directly, like in this case is 8 days. It's 50 units. Okay, so it depends on the data you get. So this is just plain super easy math. This is just 50 units a day times 7 days plus 50 units, which is gonna get you like 400 units of inventory. So whenever your retail store level drops to 400 units, you will reorder. So when your inventory level, if this is time, and this is the inventory level, remember that triangle above on the retail store? Whenever you kiss this level with your inventory, so say your inventory goes like this, whenever you kiss 400, this is the reorder point for the RS. Then you reorder, because you know that this is the time you have. This is for covering potential stockouts before you go down to 0. You will get a new order and then you will be up. Okay? Is that cool? Any questions? No questions? All right. Well, then let's hit the trail with the second example, which is a periodic multi-echelon review system. This would be let me see, an example, I would call the example 2.2. And then I'm going to go and name this 2.3, which is a multi-echelon inventory system with periodic review. All right? Cool. So in a multi-echelon inventory system with periodic review, inventory levels, in this case, inventory levels are reviewed at set intervals. Let's say weekly, for instance. And an order is placed to bring inventory back to a target level. In this, the difficult part here is in multi-echelon inventory systems. We adjust the target level based on echelon stock and lead times. Okay. So let's look at two examples. One moment. Dime.
Es que mira lo que me pasa. Lo he apagado sin querer, lo he vuelto a encender y me pasa
¿Tienes
esto.
el código?
Sí, mira. Ese es el código.
Ahora no te puedo ayudar.
¿Y qué hago para estudiar?
Pues nada, ahora no te puedo ayudar. Estudiate lo que te has escrito. Sorry about that. So we go and get the order up to level in multi-echelon inventory systems, which in other nomenclature is called CONWIP, constant work in progress. The order up to level S in a multi-echelon inventory periodic review is the target level of inventory that allocation aims to reach after each review. Okay. It is calculated by considering the expected demand during both the review period and the echelon lead time, as well as the safety stock required to cover demand variability. So the formula for the order up to level in the echelon is the average demand times the review period, how often every week, or plus the echelon lead time plus the safety stock at the echelon. So everything is the same, but this is the review period. Okay? Because we only review every week, we need to account for the maximum time. And in that time, we don't do nothing, so we need to include it in the formula. Okay? So let's get an example. Suppose the same supply chain as above. Now it uses 30-day review period, so every month. So this is T at the retail store. Calculate order up to level S. So the step one is calculate the expected demand during the review period and lead time. During T and lead time E. So this is average demand times T plus LTE. This is 50 units per day. We have the data above, that's why I don't copy them. Times 30 days, which is T, plus 7 days, which is the lead time for the retail store. So this means 1,850 units. Okay? So I'm just applying the formula. This is the first step. Okay? Step 2 is calculate the order up to level S by applying the formula, which is the demand in that period plus the safety stock which means we have 1,850 units plus 50 units equals 1,900 units. Okay? So a little bit more, as you see, than what we got before. Why? Because we only review every 30 days. And we need to account for those 30 days in our safety. Is that cool? Make sense, everybody? Yeah? All right. So now for you to make, you need to make it. I will not solve this. You can imagine why, okay? Repeat exercise 2.2 and 2.4. If the safety stock at the retail store is not known, but we know we aim for 95% safety. Hint, think about the Z score. You know the mean value of the demand, you know the standard deviation, you can calculate the rest. Okay, so this is for you to think. Please do it in order to get a good grasp of the exam. If you don't come forward with this, we can solve this, or I can give you more hints when we meet November 6th for questions and answers.